afternoon, everybody. This is Bob Debski. I'm the National Business Development Manager here at AlpsControls.com. I'd like to thank everybody for joining us today. I'm really excited about this. This is a series that has been going on for several years now, and this is the best registration we've ever had for one of these for the solution series. So we're really excited about that. I think it speaks volumes for the need for this type of discussion and this type of a solution. So we're really, really excited about this attendance and everybody's participation. It's kind of interesting. I've been in this industry since the late 80s, which I don't need to hear from anybody that that's when you were born or you were born after that. I've been in this industry a long time. And I started with one of the big three control companies. And it was very interesting early on in my career that I quoted a project to a school, two-story schoolhouse. I think it was a total of 24 rooms. It was all baseboard radiation. And I put together a quote for a building automation system. Now that quote, I don't know, let's say it was 2.7 million. Probably an exaggeration, but for the company I was working for, that was pretty typical. Put together the quote, met with the superintendent of buildings and grounds, and you know what he told me? He said he was embarrassed that he could not go in front of the school board with my quotation. He said, it's out of line, there's no way. He said, I'll just keep it pneumatic controls and we'll do our best with it. I think that brief little story speaks volumes about the fact that these building automation systems, which are infinitely customizable and programmable, that we're all accustomed to, do not scale down particularly well. They scale up fine. They do not scale down. And when you start to look at smaller buildings and the demands of the owners and operators of smaller buildings, your traditional building automation system does not fit. So here we are, 30 years after the fact, and we're now talking about what is that solution, and a solution that fits those needs very, very well. I'm going to be introducing Bob French, who is the chief evangelist for 75F. Now, anytime you've got a name like Chief Evangelist, you've got to have some passion. You've got to be very passionate about the product. And that is Bob. That's what he does. That's what you'll see will shine through. He's very proud of this product, and he rightfully so.
Bob, thanks so much for that introduction. And yes, I am passionate about this. And I hope that there'll be a lot of interesting information today. What I'm hoping to do is give you about 20 minutes of a planned presentation, 20 minutes of a demonstration of what the user experience is like, and then about 20 minutes of questions. So I really am looking forward to your questions. It really helps me understand, where you're coming from. So I'll tell you, I've been at this for about 10 years with 75F now, and I have met hundreds of contractors. And typically when I ask them, what is your barrier to growth? The most common answer I get is, I can't hire any more techs. If I just had more techs, I could grow. Well, what I want to show you today is a way to grow without hiring more DDC techs. So what I'm going to start off with is this idea that you can grow your business. You can get into new markets, and you can be doing the installation 10 times faster than a legacy system would. So that's why we fit where legacy systems don't. The story that Bob gave was just awesome about that school. Of course, anything even near $100,000 wouldn't make any financial sense to that school board. And so this mid-market has been overlooked for a long time, and this is what we built the solution for. We had to do a couple of things in order to do that. We had to figure out how to have a completely works out of the box solution. so that the programming that's associated with the DDC system was eliminated. We also bring our own network. It's a 900 megahertz wireless mesh, and we'll talk a little bit more about that. So if you take networking out of it and you take programming out of it, you can literally reduce that install down to 1/10 of what you're used to. And because it is a web forward design, it is infinitely scalable. So if you have customers with lots of buildings in their portfolio, it scales up to that kind of a scenario very easily. In fact, it's all built in. This idea of master systems integration doesn't even exist because literally everything that we do is web-based in terms of the user experience. And so everything just comes together by virtue of being a 75S system. And that turns out to be a fantastic tool for service contractors who want to sell more maintenance and service contracts and have ways of delivering them more efficiently and making more money. That's what it's all about. So 87% of commercial buildings less than 50,000 square feet don't have any building automation. That's a statistic from NREL. If you go up to 100,000 square feet, you're looking at about half or so. And so we are talking about millions of buildings that look just like this one that do not have any automation, and they deserve it. You know, this building here, I'm just looking at it, you know, it's probably in the 200 kW range. Not sure what they're doing inside of this building, but they're consuming, you know, plenty of power, and it deserves to be automated. So you guys are familiar with this. You're all in the business. What you've really had up until now is a thermostat on one end and a DDC BACnet system on the other end. So your options have been limited. So what we saw when we started this company about 15 years ago was that there's a huge gap in the market. And as I mentioned earlier, we realized that the key to gaining access to those smaller buildings was the total installed cost. If you don't get that total installed cost, it doesn't make any financial sense, and it's not going to happen. So this is what the market looks like. So there's 6 million commercial buildings in the US. This is from the EIA. And 87% of those under 50,000 square feet have no automation at all. So traditional control systems, these BACnet DDC systems I'm talking about, have, you know, this degree of complexity and cost to them. And so they're only cost justified in the biggest of buildings, say 250,000 square feet and higher. That's the domain of these traditional systems. And so what we're showing you here is that there are literally tens of thousands of good-sized buildings that are not covered. It's a green market, and it's just waiting for you to go out there and capture it. What we're doing is giving you a solution that will enable you to get out there and get it. Well, we know this because, you know, traditional controls are like Lego blocks. Obviously, we have a lot of respect and admiration for the traditional companies. I've been over to the Johnson headquarters a few times in Milwaukee, and if you go into the lobby there, you see this absolutely beautiful display of the world's first zone control system. It is steampunk, but it's not made up. It's the real deal from 1880. It was a zone control system for radiators that was first installed in Wall Street. So over the centuries, in the case of Johnson, they've had plenty of time. They've made a device and a module for virtually everything that you could possibly find in a commercial building. But you need a Lego master to turn it into something useful. And these Lego masters, otherwise known as DDC technicians, are super skilled. They're very, very busy. They have to be billed out at a high rate. And not only that, they're so busy they can't even get started on your project right now. So what we figured out was that we needed to figure out something that could just work off the shelf. So it's still the Lego blocks, still does the automation, still has devices and modules, but it's prepackaged, and the sequences of operation are pre-made. Because if you think about it, in the mid-market, of all the different terminal equipment types that are there, the sequences really don't vary very much. They don't vary from one OEM to the other very much. And so why not just pre-write all of that? Why not just predefine the analytics of the the visualizations, the time series data, the maps, and so on. Why not just make that be something that you don't have to do? It's just pre-made. So if you look at it from, let's say, more of a hierarchical view, this is something akin to what a traditional DDC system would be, stacking up from the field devices all the way up to the web, which we're calling a supervisor of supervisors, and all of the layers in between. But what we did with an IoT BMS, which is web forward, we collapsed those layers down. So now the web is the supervisor. You don't need a supervisor of supervisors. It's a redundant idea. So this is an IoT BMS, the Internet of Things. Of course, you guys know that term. We manufacture the devices and the firmware that comprise the unit controllers or the device controllers, all the way up to the enterprise platform on the web. So I saw the survey that you all filled out, and I saw that the majority of you are already providing or getting remote access to your buildings, which I think is awesome. So you already know the value of remote access and mobile apps. Of course, everyone here is probably controlling their home already with their smartphone. Of course, the logical thing is to do the same thing with commercial buildings, and that's what we've done. Here's your IoT building management system. Really, we're involved in HVAC control and air quality and energy management. So it's a BMS and EMS combined. So these are the sensors and controllers that we've designed and developed for the task. And we're going to talk about each one of them individually so you get a sense for what their roles are and where you use them. So the target market that we went after, the target customers, obviously the schools, like that story that Bob gave, churches or religious buildings, commercial office spaces, medical office buildings, retail. These are all the kinds of buildings that are going to have equipments that are very predictable, right? They're going to be packaged rooftops, air handlers, VAV or constant air volume zoning. There's going to be radiators, fan coils, heat pumps, right? That's what's going to be out in these buildings. So that's who we're going after. It's designed to work out of the box. And as I mentioned, it's a wireless system, but it's the sensors themselves are not wireless, right? The devices are wired to the equipment just like any other device would be. It's powered by 24 volts, just like any other control system. And our sensors are wired to our devices when we need a remote sensor. The part that's wireless is the communications. So there's no home run network required. And they all interconnect with each other. That's what I mean by a 900 megahertz mesh. Every one of our devices has a radio transceiver inside that becomes a node on that wireless mesh. All of that is automatic. You're not setting that up at all. You just turn the devices on and they explore and find each other and phone home, so to speak. So that 900 megahertz is much better than Wi-Fi in terms of a commercial building, in terms of the length that it can travel. It's going to be traveling more like 100 feet or so realistically, although devices are typically much closer together than that, but they go right through walls. They go through typical building construction. There are some places where that wireless mesh is degraded, and so the signal is not as strong. In older buildings where there's a lot of concrete, rebar, brick walls, that kind of thing, that's not going to stop the mesh. What that's going to do is make it so that the devices really need to be closer together. We might need to add a few more devices to get around. So that's what the implication is of the wireless communications. It's very accessible. Instead of hiring that Lego master, the DDC controller, you can hire an apprentice or perhaps someone who just is familiar with low voltage, right? Because everything is pre-configured. What we really need is someone who can power and mount and understand what equipment they're controlling, and we take care of the rest. It turns out to be super efficient too. Of course, automation is the key to efficiency when it comes to energy. automating building setback, for example, when the building goes unoccupied, and having sensors like infrared sensors that determine whether a room is occupied or not, and relaxing the set point a bit, when that happens. All kinds of other energy conservation measures, ECMs, that we support. We've been doing this for a long time. We're compatible with many prescriptive rebates from the utilities. And if you're interested in that, talk to your Alps manager, and we can get into like some examples of like ARC is a good example, advanced rooftop controls. We have a very elegant solution that provides that, and that's a prescriptive measure in lots of utilities. And so, so this is what I mean by design to work out of the box. Just to bring the point home a little bit further about this installation happening, 10 times faster. We did a couple of time and motion studies. We did a couple that are posted on our website. There's a link to it right here that you can go to, or just go up to our website into the How It Works area. You're going to see these. So in one example, we have a multi-zone air handler. We were able to set that up in about 15 minutes, 14 minutes to be exact. And it was 3 hours done with a Niagara system. And likewise, VAV zone was mounted, wired, communications were set up in 45 minutes versus 3.5 hours. So the time savings is real. And when it comes to growing your business and making do with the people that you have, because you can't hire any more techs, there's no better way to do it than this. So we have a complete turnkey, out of the box solution. It's a fully vertically integrated, which means we've developed it from the ground up. So each of these devices scales up to what's needed based on the type of equipment that's being seen. And the difference between an IoT BMS and a traditional BMS when it comes to building size is that the IoT BMS will scale proportionately to the size of the building. And this enables you to get down into the smallest of buildings with a proportional cost. There isn't a floor like you would traditionally see with a traditional system. You're probably used to a floor under which there's no building that makes sense to you because you have this, let's call it setup cost to just get started. With an IoT BMS, you're not experiencing that. So you can go into a little quick serve restaurant with just a couple of 3 RTUs and serve that customer with a proportional total cost. And it scales up as the equipment gets larger and the sequence get more complicated. It scales up into the bigger and bigger buildings. And as you can see there, we have a 75F Jace. So that's our Niagara solution to get into the largest and more complicated central plants and the bigger air handlers that require custom sequences that are not packaged out of the box with our smaller devices. So Facilisite is the name of the user interface that we've given. So that is the collection of apps, both for mobile devices and for the internet and for Chrome browsers on a laptop. And this is where you can monitor and control building from anywhere. This is the remote control and data that your service teams need to understand what's going on in a building, to see what it's doing right now, but also to see what it's been doing over any period of time since the day that the site was installed. You don't have to actually set up any sort of a trend. It's just there. And it's not limited to a number of days. Because this is all web-based and we're using the Microsoft Azure web platform, it just infinitely scales. And so we can keep that data, all the way back to this date of install. And we're not limiting the number of devices, locations. We're not limiting the number of seats either. When you license the device for a building, that license is going to be annually renewed, but there are an infinite number of users who can log on and take use of it. And it's roles-based, and we're going to have a demo of that after this, after these slides, so you can show exactly what we're talking about. So the first device I want to spend a little time with is the central control unit, or CCU. This provides a local user interface in the building. So we realize that the website and the mobile apps are everybody's preferred way of looking at the building. But I mean, what if you have a bad internet day? You still need to have some local control. So the central control unit will provide that. You can see there's multiple zones here. If you just click and touch one of those zones, you can change set point, you can change schedules, you can see what's going on. So that is going to be right there on the site. What we're doing here is offering a hybrid. So the actual control of equipment is done locally with these devices. We don't need the internet in order for the device to have control of equipment. I mean, that would not be a good design, right? So these controllers don't have to have an internet connection. If you've got this thing controlling an air handler and the internet goes down, nothing's going to change. The thing that's going to change is you just won't be able to see it, right, remotely. But it's not going to change the sequence and the required operation of those units. I think of it as like two cadences. The devices are operating on a 60-second reset. So every 60 seconds, it's going to be reevaluating its algorithm and resetting whatever control devices that it's controlling. And then the web is looking at the building more holistically on a day-by-day cadence. So minute by minute, each of the devices are resetting. And then day by day, the web is looking at things like conditioning rates and things like that. So when you are connected to the internet, you have these incredible benefits. You get remote updates. You get the day-by-day benefit of what the cloud is doing in terms of predictive startup and that kind of thing. And you're getting that remote control. These are all things that everybody wants these days. So the CCU plays that central role. It is the gateway, but it does some other things too. It is actually a device controller, as I mentioned, with a larger air handler that is beyond the capacity of our thermostat. This central control unit actually becomes an AHU controller. And so it performs that function. It supervises all of the zones that are attached to it. It also is a BACnet IP server, and I'm going to show you some practical applications of that. It's also a Modbus master, so if you need to be doing some integration with meters and like that have a Modbus interface, we can pull that right in here and get it up to the cloud. So it's doing a lot of different things. I think the star of the show, the device that you all are going to be most interested in, is the Hyperstat. The Hyperstat is something like a thermostat, except a whole lot more. It has lots of I/O. It's pretty beefy, so it can control a lot of different sequences. It has the ability to control 3 stages of heating and cooling. It can do a 3-speed fan or modulating fan. It has 3 analog outputs for those analog control devices, a couple of thermistor inputs. It mounts on a gain box. And on top of all that, it has 8 indoor air quality sensors. And those sensors would be, of course, temperature and humidity. CO2 is a super important point. That's built in. Occupancy is built in. And some other ones that are kind of cool, which we can use for monitoring, would be VOCs, light levels, and sound levels. And you can actually get a particulate matter, a PM2.5 insert, which is an adder that can plug into the device for places where PM2.5 is important. So it's an IAQ monitoring station on top of being a connected thermostat. So here are some, let's just call it prepackaged sequences that come. We call those profiles. So we apply a profile and all of the I/O that's needed for that device are predefined. So we're going to send you a wiring diagram of how to wire up the device, like what points are expected to be landed where, and you select one of these profiles and done deal. So 2-pipe fan coil on one hand and an R2 on the other. Same device, It's just a radio button during the configuration process, and then a different diagram showing you how to wire all that up. So it's going to do 2 and 4 pipe fan coils, demand control ventilation. You can do hydronic or electric heat. If you want to monitor status of the equipment at the same time, we use those analog inputs and put a CT on there. There's a profile for heat pumps. If you have that OG reversing valve, no problem. Split systems and RTUs are pretty much the same. We call that a conventional package unit. And sometimes exhaust fans just need to run on a schedule. No problem. We can just apply it to the building schedule and you're good to go. Or if it's an exhaust fan that operates, based on temperature, that's going to be built in, of course. Or, any other of the points that we have on board, you could use to control your exhaust fan. And then also built in is some options for key card and window and door sensing routines. With the key card, it's going to relax the setback. With windows and doors being open, it's actually going to turn the system off. And that's all pre-built, pre-made. All you have to do is wire in the sensor, land it in the right place the way we show in your diagram, and you're good to go. I forgot the most important point. So the Hyperstat is one of the components of our IoT BMS. But as you have seen in the last 3 slides, it's BTL certified, which means it's also a BACnet MSTP device. So you don't need the 75F BMS to make use of this device. If having CO2 and occupancy in addition to temperature and humidity is of value to you, you will find this to be a very compelling product at a really good price. And you can just add it to your existing BMS with the MSTP trunk and explore those points, and you're off to the races. So get a hold of your Alps manager, account manager, and get some of those in stock right now. Okay, Smart Node is the third of these devices I wanted to talk about just a little bit. Think of the Smart Node as being like an I/O expansion card that's not attached to the main panel. It's wireless too, and it has some I/O on it. And you just mount this wherever you need that extra I/O, and you're good to go. The most common place you're going to find this is going to be on a VAV or a constant air volume zone. So a VVT style zone or a VAV style zone. It has the I/O to control dampers, say hydronic reheat or electric SCR reheat, all those things that you would see in a typical VAV box. And we have pre-made sequences of operation for a VAV with reheat, without reheat, with a series fan, parallel fan. All that stuff is pre-done. So all you have to do is wire it up the way we show you, select the right box, and you're good to go. And so to complement those devices, we have designed a series of digital sensors that go and support our system. And these here are the most important ones. There's others too, but I just wanted to show you these first. Over on the left, you see something that looks like the Hyperstat. That is not the Hyperstat, because the way we designed Hyperstat was in 2 parts, a front and the back. And the back is the controller, actually the thermostat part that controls a package unit. The front is more the IAQ sensing portion. So when you pull it apart, the front becomes just an IAQ sensing station. So this would actually wire up to a Smart Node and a VAV box. So if you want to have an absolute state-of-the-art kick-ass VAV experience, then you would put this in the room. And so you would have temperature, humidity, CO2, occupancy, all those things feeding into your VAV sequence. So that's what that is on the left. That's the Cadillac of our sensors. The next one you'll see in the middle, the little orange one, is a differential pressure sensor. You'll need that for your VAV application if you want to measure flow. That just hooks right up in series with the rest of these sensors. The bigger one that's second from the right is the multi-sensor. This was designed expressly for Title 24 compliance. So it has temperature, humidity, CO2, and occupancy all built into one sensor. It's about 2 inches or so in diameter, just sits on the wall. And now you can do demand control ventilation by zone and occupancy. And just with that one sensor and the smart node on the VAV box. And then over on the right-hand side, the smaller sensor there, that's the wall sensor. Let's just call that your entry level. That's your temperature and humidity sensor. This is the one that we use by the thousands, which you need for any sort of a zone control or room sensing kind of option. And the one on the bottom is a temperature and humidity sensor also, but it's designed expressly for ducts. And it has an extensible core. I see 2 of them installed on this one. So we can get right down into the center of that duct, and it's a very high precision measurement of temperature and humidity in airstream. So what I'm going to do now is take you through some common applications. I've just talked through what the capability of all the controllers is. And so now how do you apply that to practical scenarios? So the first one is, let's just call it your packaged equipment. This is probably going to be one of your more common small buildings. It could have a bunch of rooftops on top, or maybe it's got some fan coils or heat pumps. You just put a Hyperstat on each one of those devices. They're going to communicate wirelessly through to the CCU, which is the gateway, which brings everything online. And as I said earlier, we have pre-made profiles for rooftops and split systems, heat pumps, 2 and 4 pipe FCUs. You could do unit heaters. It could be staged and or modulating equipment. And in some cases, people have asked us to put these in, not controlling anything, but they want that IAQ sensing station in key places so that they can monitor all those IAQ points. So this is a super accessible one. This is one that you can do now today. If you have a customer who's been asking you to do some of their smaller buildings, say 25,000 square feet or whatnot, this is something that you can put in right now. Now, I'm sure that you're familiar with, let's just call it the Wi-Fi thermostat. There's a bunch of brands out there. But the point I want to make about this is that this is designed for commercial applications. So the user experience is totally for that commercial customer. It's not a residential application that gets stuck into light commercial. So it's a true BMS. The kinds of things that a facility manager would want in a professional setting is all there already. And you could use the same system to control more complex systems like a VAV, for example. So if you go and get a Wi-Fi thermostat, you're not going to control a VAV box with that. So if you're looking at this solution, you can mix and match. You could have some of these Hyperstats controlling packaged equipment in one part of the building, and a CCU and smart nodes controlling VAV zones in another part of the building, all coming together into the same user interface. And you just can't do that with a Wi-Fi thermostat. So the next, this is probably our meat and potatoes, is zoning, airside and hydronic zoning. So when we're zoning, we're going to use that CCU on the air handler, and then the smart node is going to go on to each of the dampers. And we offer a smart damper that has a Belimo actuator, and it has a temperature sensor built in. But if you're retrofitting an existing damper, I recommend that you take the old actuator off. You don't have to. If it's an analog actuator, we're going to be compatible with it if you want to keep it. And then we need some kind of a sensor. What I'm showing in this case is just a simple wall sensor, but it could have been any of those sensors that I'd shown you on the other slide. This can be set up for both constant air volume and for VAV, and also for radiators. I mean, it's a good application for, say, the northern states, northern New England, where there's a lot of buildings that have radiant heat on the perimeter with a manually operated zone valve. Those can be retrofit with an actuator. There's some products out there that are very affordable that we're compatible with. And now you can turn that perimeter radiant system into an actual DDC zone controlled system at a very, very good price. And remember, I mentioned earlier that we have a Modbus master as one of the elements of the central control unit. So what we're finding is that we're offering a super compelling cost basis for doing metering. So metering could be either like whole building meters or sub-metering for people who want to really break down their consumption. And so, energy meters, water meters, gas, BTU meters, they all have Modbus interfaces. And here's the cool part. We would actually integrate that for you. So we would deliver the CCU already integrated with the meters that you're planning to use. Just drop it in your lap. All you got to do is put it in and you're done. Okay, so this is going to put a big smile on all your faces. I could just see the smiles out there right now. At least I hope so. So with that BACnet integration, right? So you can blend the best of both worlds. This system is not intended to cannibalize your existing business. It's meant to complement it. It's meant to expand your capabilities to go farther and do more with the same text that you have. So over on the right, you've got your ALC, say your central plant or existing BMS that you need to plug into. Why do the air side with that? We've got a wireless system that you can just throw in there. So all the VAV boxes can be done, the air handlers can be done, any of the package units, rooftops or whatever, they could all be done and wirelessly communicating with the CCU. And then through BACnet IP server, you just pick up those points into your existing BMS. And now you have the best of both worlds. So I have talked about a whole bunch of unique advantages here, right? I think that you're starting to get the idea of where this could go. Because remember, there's no need to program anything. You're just configuring and tuning things. They're wirelessly communicating with each other. So we're bringing our own network, reducing or eliminating most of that cost. I'm sure you picked up the CCUs need to be connected to the internet. So there is some networking needed to be done there. Most commonly, about 95% of our sites are just Wi-Fi because a lot of times the owner has already created a secure Wi-Fi for guests. We don't need anything special. We don't need a static IP address or VPN or anything like that. Just a Wi-Fi signal is enough. We'd like to see it be an Ethernet drop just to reduce the, let's say, downstream or years from now reliability. Because Wi-Fi seems to come and go depending on what router's there. And I'm sure you guys know a lot more about the the trials of working with networking than I do, but I know that they're out there. So we eliminate almost all of that. And so for the VAVs, I didn't mention this, but we follow ASHRAE Guideline 36 out of the box. If you are not familiar with Guideline 36 yet, I recommend that you do. We follow Guideline 36 for both VAV terminal units and also our central plant. When we pull out that JACE and build a JACE panel for you, we're going to be using Guideline 36 by default. And of course, that's an interactive process between your team and our team. So it'll end up being what you want in the end, but Guideline 36 is what we're going to come out with. That's going to be our first suggestion to you when we get started. We have learned over the years that supporting our partners is even more important than the solution that we've created itself. And I know it was kind of a hard place to come to. We thought we were so proud of our solution. We thought it could just, speak for itself. But we learned that supporting our partners is just absolutely key to success. So I've got 3 things here that you will be very pleased to hear about. The first is we offer professional certifications from entry level all the way up to sophisticated integration and certifications that are done. We have a design and implementation team where we will look at projects, do the design, and actually do the implementation of the setting up of the systems and even the programming of a JACE system if you want it all for you. And of course, this is all backed up by our support and services team. And so I'm going to go into those in just a little bit more detail because this is such an important topic for you. So in the professional certifications category, we have an entry-level class, which is just online. It's done at your own pace, and that's a free, type thing to get you started. So, but the advanced classes are all done in person. And so we have every 2 months, we have a set here. And then we can also go to your site when there are enough users to make financial sense. So our design and implementation team will actually build out a CDD controls design document package for you. We'll have the logical diagram, the wiring diagram, the points list, the sequences of operation will all be documented for you. We also build, as I mentioned, JACE panels. So we would actually back you up by designing and building and programming a JACE panel for you, and then deliver it to you with an open NICs. So your customer doesn't even need to know that we did it for you, but you're going to walk in there and mount and wire it. And then if you want, we'll have an engineer come out and support it and help you start up the system. So it's a really rare thing. OEM controls manufacturers just don't do this, but we do. And then, of course, our support, services are the star of the show for us. Almost always the thing that people like about us the most is our friendly and accessible staff. You're not going to be waiting for hours to access these guys. We also offer managed services, which is a extended service where you can get more time from us than you would by default. Whereas if you want us to be working on your behalf and doing remote and proactive sweeps for you, that's a service that's available. Okay, so what do you need for making a sales call? What I would recommend is you get a hold of your Alps manager, ask them what kind of literature, what kind of sales support is available. All these things are there for you, and just go ahead and get a hold of them, and you can get started. But what I'm going to do now is switch over to the web and show you just briefly what the user experience looks like. I see that we are running out of time. I'm so sorry that I just got too excited about all this. And I had so much important information to give, but we only need a few minutes to give you a feeling for what the web is like. So hang on just a second. So this is Facilisite. This is a secure roles-based access. So based on your credentials, you're going to be able to see buildings based on the access you've been granted. So you could go in several different roles, from administrator through a view only, and then the least capable one is what we call the occupant. And the occupant actually has access through their mobile phone, just their zone. And the only thing they can do is override the temp. So it's kind of like a thermostat in your pocket approach and applied to a zone. So imagine a VAD system where the VP is in the corner office and wants to control her temperature from her phone. You can give her access to do just that within a temperature range, of course, that you approve. So any of the buildings that you see, you can dive into any of them. I'm going to come into this one here, the US sales demo. This is a site that you can get access to do demos on your own. Just talk to your Alps rep and we'll get that done. So the first thing that you're going to see is a heat map. This is going to be showing by temperature what the building is doing. So I can see that green is on set point, red is warm, and blue is on the cool side. So hang on just a sec. So in addition to seeing temperatures, we can create overlays. So by clicking on this filter over here, you can create an overlay of your own, or you can create an overlay and share it with others. And when that happens, other people can take advantage of your work. So let's just take a look at this in terms of humidity instead of temperature. This is something that even the facility manager could develop for themselves. They're not very hard to build. And as you can see from the list there, there's all kinds of different overlays. Any point that's in the 75S system could be turned into an overlay like this. And of course, you can dive into any one of these zones. You can see what's going on. This one has an infrared occupancy detector on it, so you can see that the set points are tight when it's occupied and then relax when it's not occupied. So you can see, what's going on in that zone. You can see all the points that are there. We're going to show you by default today's data, and then you can go back and look at any date and time that you want. So I can look at last week, but for now, I'm just going to look at what happened yesterday, and you can see what's going on. And this will be really helpful to you, your techs, when they're providing service, to kind of get an idea, the history of what's been happening in that zone before they roll the truck to go out there. We, of course, have got other analytics that can be built. Analytics that we've built ahead of time are all designed to be like the most commonly needed ones. But if you want to do some sort of analysis, you can just make your own charts and graphs set up in sort of a wizard format. We also provide alerts, of course. You can come in and look at any alert. These are all pre-made alerts. We can write custom alerts for you too. So you're not going to get notified of these unless you come in and you opt in. So if you come over here to your account and you come into notification management, you can select the site that you're going to be dealing with, and then you can opt in to get notifications of those alerts through email, text message, or if you have the mobile app running, it'll do a push notification on there. So that's just a quick preview of what the user experience is like. I'm going to quick sharing here, and I think we have about 10 minutes for questions.
Okay, thanks, Bob. This is Alan Lopazinski from Alps Controls, and I've got a handful of questions already here in our queue, so let's get right to them. James Fonfera with S&W Controls wants to know, our portfolio has buildings down to 4,000 square feet to 20 to 100,000 square feet to over 1 million square feet. How does this interface with Tritium BACnet devices as our monitoring system is built on?
Okay, I showed some examples of ways that we can interface. We do have a JACE driver. That is one way that we can do an integration. If it sounds to me like that one's going to be one of the ones you'd want to consider right away. So what I would recommend is that you would use our system for all of those buildings that don't have any automation yet. So your smaller buildings all the way up to the largest that you have that are not covered already. And so all of those will be brought into this user interface I just showed you. And then using our integration path, you could bring your data into that same platform. We also have a 75F data pump, which is a universal protocol converter for any other type of system if you don't happen to have a JACE on site. So that's another way of getting data up into the cloud. We could also go the other direction. You could use that JACE driver if you wanted to pull data from our system into yours. So those are some paths that come to mind right away. I didn't spend very much time talking about our API, but we have a very deep and robust web-to-web API. We are a web company. In fact, that whole user experience I just showed you was built using our own API. So it's unlimited, the number of things that you can do with the data that you get through the web API. So that's food for thought for you.
Josh Murray would like to know, what would you suggest using to get analog signals from compressed airflow meters located throughout a building wirelessly back to a CCU? Also, can you transmit information on the HART protocol that is sometimes on the analog signal?
Okay, I can't speak to the HART protocol because I'm not familiar with it. But as I mentioned, the Smart Node and Hyperstat both have analog. They have two analog inputs. So we could bring that signal in through that analog signal and then bring it to the CCU and up to the cloud. And then you could then apply a transformation to it to determine what the scale should be. So that is, I think, the most straightforward way of integrating that data. Both the Hyperstat and the Smart Node are wireless communications back to the gateway.
Okay, we have one person who wants to simply know, what is the cost?
Oh, that's a good question. Of course, you're going to want to talk to your Alps account manager to get pricing, but I can tell you that the whole reason for building this system was to really be disruptive in cost. There's no way that we could get into the mid-market and into small buildings unless our cost basis, the total installed cost, was well below what the industry had experienced so far. So I can't give you details, but you can get details from your Alps account manager. In my experience, I had seen a equivalent 75S system total installed cost being about half, or in some cases a third of what the traditional DDC BACnet system would have taken to do the same job. So it's kind of I say high level answer, but you can get details from your account manager.
And real quick here, Bob, I've already completed the sales training. I will go through the level 1 training, and then I'll be back out in Minneapolis with Bob next week going through the level 2 training. So, as the subject matter expert at Alps Controls, I'm there to support our regional sales managers and customers. So we'll be up to speed and able to help people put together quotations and budgets going on after next week.
We'll hope for good weather on Thursday, Bob, because we're going out on a boat cruise that night.
Yeah, as long as a hurricane passes well to the south, I'm okay with that.
Okay, we got a bunch more questions ready to go. Bob, sorry if I'm going to mispronounce your name, Bob Simar. What is the range between controllers for the wireless connection?
So the nominal range is 100 feet, and that would be the limit of what we would recommend inside of a building. When you get into a line of sight situation where you have very, very large spaces where there aren't any walls, it can go out farther, but 100 feet would be a nominal range. And in practice, it's more like around 50 feet. If you think of it, you look at a blueprint of a VAV system, for example, it's not that far from one VAV box to another.
Okay, and Bob actually has another question that he's submitted here. Do you have monthly or yearly fees to the front end?
Yes, there is an annual subscription that pays for a number of things. It pays for consumption, which is what Microsoft charges us for putting everything up on the cloud. It pays for our support team, and it also pays for all of our updates. So it's kind of like a maintenance plan you would get from a traditional system. It's all included, though. All three of those are included. And we do a lot of updates. We are a high-tech company. The features that you'll see on the web are constantly improving and adding. And because it's an IoT BMS, everyone who subscribes gets the benefit of every feature that we add.
Hey, Bob, just real quick, I went through a budget process that you helped me with earlier in the week. We looked at a project that had roughly 60 heat pumps, had a CCU on the front end. And just to give everyone some idea of scale, that total subscription, annual subscription, came in under $1,500 a year. So, if you're familiar with some of your subscription costs for Niagara licensing and so on, that should give you some idea of scale compared to, with what you're probably familiar with. It's a fraction of what you're probably accustomed to.
Jeff Boston with CCI would like to know, is the wireless comms Zigbee?
Oh, great question. It is not Zigbee. It is a proprietary protocol. 15 years ago, when our founder and CEO, Deepinder Singh, was evaluating how to get this done, he looked at Zigbee first. Back in those days, it was a 900 megahertz mesh. But what he determined was that Zigbee, because it is meant to serve everyone, was not an efficient protocol in terms of the amount of packages that it could deliver efficiently. There's a lot of overheads because it needs to be good for everybody. So he came from Verizon. He's a networking geek. So he developed his own protocol written expressly for 75F. And it is super efficient. It is purpose made. And there are hundreds of thousands of zones operating on it now. It's the bomb.
Jeff Sutton asks, how would you get these local 900 megahertz device data outside the building to the IoT front end?
Okay, so that's the purpose of the central control unit. So just some rules of thumb in terms of the CCU, because we're using it as a gateway amongst those other things that I mentioned. So we need at least one CCU per building. It's going to be somewhere in that building. Ideally, it would be centrally located so that all the devices can talk to it directly without having to hop, because that's going to be the most efficient. We're going to need one per floor in a multi-floor building, because the communication works much better laterally instead of covering multiple floors. So we'd want to have one per floor. You need one per zone system. And so those, following those rules more or less is going to help you figure out how many of these gateways we need in a building. And by the way, you really can't see that when you go online and look at it from the supervisory point of view, the fact that there are many CCUs in a building, because it all comes together in a logical sense based on the floors and the zones, the way they're physically laid out. So you can have as many gateways in the building as you need in order to accomplish that communication task.
Okay, we have a question. Someone feeling shy, they didn't give their name, but they want to know, could the wireless signal create interruption to the building Wi-Fi or mobile network?
So that's a really good question. The 900 megahertz band is far away from the Wi-Fi band. Wi-Fi is 2.1 gigahertz to 5 gigahertz. The 900 megahertz was expressly set aside for building automation. And that's because it's far away from Wi-Fi, but also more important, the wavelength is longer. And the longer the wavelength is, the less bothered it is by building structures like walls and the frames and so on. So we have not found it to be interruptive for the most part.
Sam Galbraith wants to know, are the actuators rebranded Belimo units? What kind of warranty is available, and is it consistent across the board or based on the component type?
Yeah, that was a very astute observation. And we're proud to say that Belimo decided to choose the color orange because they were inspired by the 75F orange. You all know I'm joking. It just happens that we have the same color. Yes, Belimo makes those actuators for us. Yes, so that's a Belimo OEM. The warranty is 1 year on all of our hardware, regardless of the type of device. And I believe those are the two questions that I heard.
William Vargo has sent in two questions. His first one is, will we get a copy of this presentation? And hey, William, I can even answer that one. Yes. We will be doing some minor edits to this in the next couple days, and we'll have it on our YouTube channel, and we'll make sure we send it out to all attendees. William's second question is, what protocol is the wireless commissioning tool?
Okay, so the wireless commissioning tool is using Bluetooth. We use Bluetooth only temporarily as what we call in near field communications, only during commissioning process. So that CCU that I showed you is actually two parts. The back side of it is the control mode, and it has all the relays and the analog I/O and the radios and all those things on that control mode. And the front of it is an Android tablet, and it's designed to just pull right out. So when we do commissioning, the only thing we need to do is assign a name to each zone, and it'll pick a channel that's the next available channel in our spectrum. And so you go around room to room, naming each room and assigning those names and the channels. That's super easily done using the Android tablet. And so that little task is done with Bluetooth. and that information is just temporarily stored on the tablet. So then when you bring it back to the subbase, the control mode, snap it in, then it will all be transmitted to the cloud and then recommunicated through the 900 megahertz mesh. And then Bluetooth is not used anymore.
Okay, we have a question from Matt Leslie, who would like to know, how many devices can be connected to a single network to the CCU?
The CCU can manage up to 48 devices. We typically find there's only about 20 or so that would be connected to the CCU, only because of the way the building is laid out in terms of how far away the zones are going to be. So 20 is typical and 48 is max.
Dave Watson would like you to please describe the wireless mesh. Each node is a receiver and transmitter, right? Do they self-configure into a hierarchy? Are there tools to observe the percent availability, signal strength, etc.? Most similar to what other wireless mesh design?
Yes. Okay. I think I've got all those questions. So they do create their own hierarchy. They are going to be assigned to a central control unit, and each CCU is going to be assigned to a portion of the spectrum. So we call that a channel ID. So they're going to sequentially move from channel 1000 up to whatever increment is needed. But each CCU will occupy a different chunk of that spectrum. So CCU 1 would have, say, channel 1000, and CCU 2 would have channel 2000, and so on. And all the devices that are associated with CCU number 1 would be in the 1001 and incrementing from there slots. So that's all automatic. You can choose other slots, and there's some times when you might want to move a device like that for some reason or another. We had to do a lot of that sort of work with a large building we did in Singapore. We had 1,500 zones. Those buildings are very tight, very small. Well, it's a large building, but they're very dense, is what I meant. So we had a lot of tweaking that we needed to do, and all that could have been done or could be done with the devices themselves. No other aids are necessary. You don't need laptops or other sort of meters to go along, because we do have analytic tools built in, so you can see the signal strength and do that tweaking that you need to do on site with the devices themselves.
Frank Kilyanik from NRG Controls North wants to know, where is the product manufactured? Thanks.
Yeah, so we manufacture in a lot of places around the world, in Vietnam, in China, and in India and the US. We bring it all together here in the US. Our stockroom is right here in Bloomington, Minnesota. And so we can deliver product very rapidly by keeping that inventory. Our supply chain looks at forecasts, so we know like how many months ahead of time we need to start manufacturing new printed circuit boards. The surface mounted components are all purchased here in the US. They are delivered to our contract manufacturers in Vietnam. Those finished boards are sent to India, where all the assembly work is done. The plastics and the electronics are brought together and put into packaging and that kind of thing, so that when we ship it out to you, it's all prepackaged, tested, and ready to use.
Rick Joyner would like to know, if I have a customer who will not allow communications through their firewall, and we planned to just bring this into our existing BACnet system, will there still be a yearly fee?
Okay. That is something I need to get back to you on. That's a really good question. I totally get your reasoning for it. So I promise that we will get back to you on that.
Dave King would like to know, will one CCU serve as both the wireless gateway and a BACnet integrator?
Yes, it does both those tasks. We're going to be using in that case, we're going to need to use our Ethernet drop and the Wi-Fi communication capabilities to accomplish it.
John Grad wants to know, do you have BACnet points tables for all of the controllers? What systems have you integrated with, i.e. Allerton, Honeywell, Distech, JCI, etc.?
Yeah, so we have done quite a bit of work. As I mentioned, we have our own JACE, the 75F JACE and Workbench and driver that we've developed. So we're most familiar with that platform. You may have seen that Siemens invested in us last year. So we've done some work with them with using the thin framework. That's from J2 Innovations. And I know that our partners around the country have integrated with other systems, although I can't off the top of my head give you specific examples of what systems. And as far as the BACnet tables go, I don't know the answer to that, and I will find it.
Here's a quick one from Brandon Bertram. What is the battery life for the sensors?
Okay, so none of the sensors are battery powered yet. They are all wired. As I was describing, the only wireless aspect of our system is communications back to the CCU gateway. We are developing some battery-powered sensors. We do have an occupancy and temperature node that takes two AA batteries that will last 2 years. But that device doesn't control anything. It's really just for bringing temperature and humidity data back to a gateway. For the purpose of having multiple temperatures influence the load calculation of a large system. But these other sensors that I showed you, like the picture that I showed you, those are all wired using the 75F, what we call a one-wire digital bus. It actually has 2 wires, but no, actually 3 wires to take it back. But we call it the one wire because power and communications transmit that way.
Okay, Sergio Galindo would like to know, hi, is it possible to control or monitor lighting, access controls, and CCTV, or maybe to integrate with third-party panels?
If we were going to be doing any of that type of integration, we would drop over to our JACE strategy. The devices that I showed you and talked to you about today wouldn't have that.
Brian Brazel wants to know, are these considered made in the USA for government projects? Do they require a cloud connection, or can they be standalone to a BACnet DDC?
Yeah, the Hyperstat for sure can be standalone to the back. I mean, an MSTP trunk back to your BACnet system for sure. Okay, so that is a no-brainer. The rest of the system would be integrating through BACnet IP server. So when it comes to not needing to be connected to the internet, in either of those scenarios, we would not need to be. However, I don't know if we qualify for made in the USA yet. I would have to look at that because I know there are rules for how much of the manufacturing is actually accomplished here in the US. So I would say we're probably not going to qualify for made in the USA. And so I would have to research that to be sure, though, because I don't think we would be. Because I think it's 50%, if I remember. And I know that we're not doing 50% here in the US.
Okay, Tim Snyder asks, is there an option for custom programming or just the canned?
Yeah, that is the other side of the coin, right? On one side of the coin, everything is pre-programmed. All you have to do is configure it, and you can use tuners to fine-tune the way it works. But the other side of the coin is that it's not programmable. And so if you really need a programmed system, then there's very excellent systems out there like ALC for that. If you wanted to do any programming, by default, we're offering the 75F JACE. That is available if you want to use it and set up your system, yourself. So, that would be one path for custom programming. But the devices I showed you, the CCU, SmartStat, SmartNode, none of those have any sort of programming interface on them.
Okay, Dan Nordstrom would like to know, is Facilisite sold directly to the building owner or occupant, or is that run through the installing contractor?
We offer the first year is going to be included in that first quote, right? When you get a quote for your project, that first year is going to be in there. The second year is up to you in terms of how you want to run that billing. We'll take care of it if you don't want to, but we really encourage you to do it yourself, because we believe that what we're doing is enabling your service and maintenance business, right? So what we're expecting you to do is to sell the system through so that you can get these remote control and data to make your service projects more efficiently executed, and that you will bundle these fees inside of your own contracts. If that were to ever expire and the customer fired you, hopefully that'll never happen, we're going to want to get that payment from them directly at some point if that's the scenario that it comes to. But you're in the driver's seat. That's the answer.
Chuck Abel would like to know, what are the costs associated with the training, virtual and on-site?
Okay, so the introductory class is free. This is about 4 hours long. It's called Installer Level 1. That's the virtual class, is self-paced that you can take. I'm pretty sure you'll need to talk to your Alps account manager to find out what the costs are for the next levels. We have Installer Level 2, and we have some integration and other advanced classes that are available too. So talk to the other Bob.
Not to confuse things. Yeah, it's just have anyone reach out to us and we can put together the pricing. The pricing is far less than what you would spend going down to Richmond for tritium training.
Okay, we have a pair of questions from Rick Joyner, back to the board here. His first one is the BACnet in the device or only in the gateway? And then he's also asking, only one flavor of room stat? How about if we only need if we only need room temp or room temp and humidity? Not every job needs temp, humidity, and CO2.
Yes, very good point. At the moment, we only have one flavor of room stat, and it's the one that I showed you, and it's I would say it's the most advanced stat available on the market because of all those sensors that it has. But we do have a continuous flow of future products that we're working on, and so we have heard this question, and we're answering it with a lower cost thermostat, which will be lighter weight. It'll have less I/O. It'll be battery powered, and so it'll fit into like the smallest of buildings. But I can't give you any sort of a date on that, but I just want you to know that our product development team is always innovating and listening to the market and coming out with new products. So we hear you on that front. The other question you asked is about where BACnet is. There's two BACnet integrations that I mentioned. The first is BACnet MSTP on only the Hyperstat that's on the device itself. The other BACnet integration is BACnet IP server, which is on the central control unit. And the advantage of that is that you could have a CCU running, say, an air handler and 10 VAV zones, and have that be just like, say, one tenant and in an existing building with an existing BMS. So through BACnet IP server, you could go ahead and retrofit just that tenant space, and then it could be supervised by the existing BMS through BACnet IP server on the CCU.
Bob, if I understand correctly, the fully featured stats are required to implement guideline 36 sequences, which include things like the ventilation rate procedure. So in order to do that, you are measuring temperature, humidity, and CO2. Also, the proprietary dynamic air balancing control routine also utilizes those sensors. So I believe those are inherent to those energy savings functions that are built into the system. Is that correct?
Yeah, that's correct. But remember that we had like a good, better, best option for you when it comes to the sensors. The good solution is temperature and humidity, which doesn't give you that CO2 and occupancy that you want. The middle one, the better one, is the multi-sensor. That's the one that's about 2 inches diameter. It has all four. That again was designed expressly for Title 24, which requires this already. And then the best one is the what we call the HyperSense, where that's where the whole front side of the Hyperstat is pulled off and turned into a giant sensing station. And those can be applied to constant air volume and variable air volume zone systems.
Thank you.
Sam Galbraith would like to know, is there an online demo available? We work extensively with owners, so the education before the project is a focal part of our offering versus bid spec.
Yes, sir. So get a hold of your Alps account manager and get a username and login for the demo that I showed you today. That demo is not connected to live equipment. So when you come in, it has full control, but just between you and me, it's not controlling anything, so you can't hurt it. So that's the demo that you would use for that. It's a 3-story medical office building.
We have 2 more questions from Dave King. One is, can you see graphs and trends directly off the central control? And the other one is, using an existing BACnet controller tower plant with an integration, will the central controller lock out compressors on pump failure?
Okay, I'm going to answer the second question first, just because I want to use that. So what I would imagine you're doing is you've got your DTC BACnet system on the central plant. So that means that you're controlling that equipment. And what you'd be doing is pulling data from the central control unit from, say, the lease spaces or the tenant spaces, or actually all of the terminal equipments. So you're pulling those points into your central control unit to use to enhance your algorithms. So we would not be controlling anything in the central plant with the CCU, but we're just exposing data for that we're collecting out in the lease spaces from that terminal equipment for you to use as you see fit in your central plant. Okay, that's why I wanted to answer the second one first, because now I don't remember the first question. Could you ask it again?
You got it. Can you see graphs and trends directly off the central control?
Yeah. Okay, no. The central control unit is just the user interface that gives you that local interface to, if you don't have internet, you can still change your set points, you can change your schedules, that kind of thing, those essential things. But FaciliSite, either through the mobile app or the website, is how you would see all the analytics that I was showing, or the trends, the data.
Bob, I think the original second question, which had to do with the central plant controller, I'm assuming that if the condenser water temperature went up to, let's say, 90, 95 degrees, or you sense that there was a lack of flow, I'm assuming, or I think the question was, can you take that information through BACnet and then lock out the compressors on each of the water source heat pumps to ensure they don't go off on high head? I believe that was the intent of the question.
I see. I don't know. That's another one for me to look up. You guys are keeping track of what I'm going to look up now, right? Because
we're recorded.
Yes, we're recorded. Okay, that's another one for me to look up.
Yes.
Okay, it looks like we might actually be down to our last one. Dale Richter would like to know the I/O point capacity of the CCU.
The CCU has 7 relays, 4 analog inputs. I'm sorry, 4 analog outputs, 2 analog inputs, and 2 thermistor inputs. It has a RS-45 jack and a USB jack, and a a 75F1 wire digital sensor bus jack.
All right. I think we have made it through all of them, believe it or not. The hamster who is on the wheel inside my computer is thoroughly exhausted.
Yeah,
If
you guys
we did
wore me
miss
out,
any,
too.
I will look back through our list and the questions and answers. Don't worry, I've got them all here in front of me. I won't miss anybody. And if I find a question that we didn't answer, I'll make sure to get it to Bob and Bob, and they will reach out to you directly and answer those questions. I do appreciate all those questions. That was a very robust discussion, and thanks to both our Bobs for hanging in there, and all of you as well.
Yeah, I appreciate it. That's the most questions I've ever gotten. So I have high expectations of this group.
We'll deliver. No, thank you for everyone for participating. It was, and Bob, in your time. It was a great webinar. Thank you.
Thank you.